Section 5.2, Part 2. In this section, we are talking about multiplicity, and multiplicity is where you are going to have multiple of the same zeros, and the multiplicity is going to affect the way the graph behaves. If the multiplicity of a zero is even, it is going to cause the graph of the function to bounce at that zero. If the multiplicity of a zero is odd, it is going to cause the graph at that zero to go through the zero. Let's look at our first example. We're given y equals x cubed minus 4x squared plus 4x. The first thing we're going to want to do is factor this. So they all have an x in common. So we factor out an f, and that leaves me with x squared minus 4x plus 4. So now I'm looking for two numbers that multiply to positive 4 that add to negative 4. So minus 2 and minus 2. Bring down the x out in front. Okay, so I can rewrite that as y equals x times x minus 2 quantity squared. Okay, so let's find our zeros now. So set x equal to 0, set x minus 2 equal to 0. So x equals 0 and x equals 2. Okay, well on this factor of x, it has an invisible exponent of 1. So this is going to have a multiplicity of 1, which we don't normally say, but 1 is an odd number, so it's going to go through at that graph. Okay, x minus 2 has the 2 as the exponent, which is going to make this have a multiplicity of 2, which is going to cause my graph to bounce at that instant. So now let's talk about the end behavior so we can continue to sketch our graph. So if you look up here at the very beginning, you started with x cubed. That's an odd and it's positive. So the end behavior is down on the left side and up on the right side since it's odd and it's positive. Now let's find the y-intercept. To find the y-intercept, we are going to plug in 0 for x. So 0 to the third power minus 4 times 0 to the second power plus 4 times 0 is going to give me a y-intercept of 0, 0. Okay, so I'm going to graph my zeros first. So at x equals 0, it should be going through. And at x equals 2, it should be bouncing. Okay, the end behavior is down on the left, up on the right. So you go through at 0 and you are going to just touch 2 and bounce back up since it had a multiplicity of 2 at x equals 2. Example 2 is different than example 1 because it's already in factored form. So that means we get to go straight from our factored form to find our zeros. So we set x plus 2 equal to 0, subtract 2, and you get a 0 at negative 2. Set x plus 3 equal to 0, and you get a 0 at x equals negative 3. Now I know I forgot to do this in our first example. Remember, zeros are points on the graph, so you have to write it as the point negative 2, 0, and the point, it would help if I wrote this problem down right. Okay, it was x minus 3. So to move negative 3 to the other side, you add it. So this would be the point 3, 0. Sorry about that, guys. So then we need to look at their multiplicities. So since x plus 2 has an exponent of 2, that means it has a multiplicity of 2. So at the 0, negative 2, 0, it's going to bounce instead of going through the 0. Okay, x minus 3 also has a multiplicity of 2, which means at the 0, 3, comma 0, it is also going to bounce instead of go through. Okay, let's find the y-intercept. So to find the y-intercept, we plug in 0 for x, so we get y equals negative 0 plus 2 squared times 0 minus 3 squared. And when you multiply that all together, you get 0, negative 36. Okay, now that's a really large y-intercept, so I might just rough where that is on the graph since it is really big, but I just wanted that to be an extra point for us. Now let's talk about the end behavior. So since it's in factored form, I have to count my exponents to determine the whether it's even or odd. So I have 2 exponents here, 2 exponents here. 2 plus 2 gives me 4. 4 is an even number, so it's an even degree. And then since out in front is a minus sign, it's even and it's negative. So even negative means it's going to be down on the left side and down on the right side. Alright, so we are going to start by graphing the 0, negative 2, 0, and then the 0, 3, 0. Okay, 0, negative 36 is all the way down here, and I'm going to label that as that point since my scale doesn't exactly match. Then as x goes to negative infinity, f of x goes to negative infinity, it's pointing down. And then as x goes to positive infinity, f of x is pointing down. And remember, both of these have multiplicities of 2. So that means instead of going through the 0, it's actually going to bounce. So I'm going to start, I'm going to come up, I'm going to touch the 0, I'm going to come back down. I'm going to go through the y-intercept, I'm going to come up, touch my 0, come back down. And that is a rough idea of what the graph looks like.